So we need to go into complex numbers a little bit at this point, and I'm going to assume you have some background information from a previous class, but maybe we need a little refresher because honestly, complex numbers do not come up a lot in mathematics, but when they do, they are important at times. So look, memorize this. I equals the square root of negative 1. All that stuff that we've told you about, don't take the square root of a negative. Generally, you shouldn't, because as soon as you do, you leave the real world and you go into this imaginary number land. Not to say that imaginary numbers don't exist, they exist in mathematics, but usually, like with graphing, we try to avoid them. So keep this in mind. I equals the square root of negative 1. That's one of those definitional things. And when you have a complex number, what I mean by complex is a number that has a real part and an imaginary part. You can have a purely imaginary number like I right here. That's purely imaginary. There's no real part to it. But a lot of numbers have a mix of both. And the way we write those is typically we use the term z because I guess x and y are taken. We say z equals this real part a plus this imaginary part b, and we put the letter I next to it to remind us that b is an imaginary part. So if you had, say, as an example, let's say real part was 5, imaginary part was 7, you would write this complex number as 5 plus 7i. Okay? Now, let's get into one more example before we start getting into the arithmetic side of things, just how you write stuff. Simplify the square root of negative 9, which we've always been told don't square root negative numbers, but if you had to simplify that using complex numbers, here's how we would go about it. I would say negative 9 is just equal to the square root of negative 1 times the square root of 9, right? No arguments there. So square root of negative 1 is I, and the square root of 9 is 3, so this is really just 3i. All right. Now, a little bit more about multiplication of these I terms. We know that I is the square root of negative 1. So what is I squared? Well, if you think about what a square does to a square root, those are inverse operations like plus and minus, or multiplication and division. When you square a square root, you're making the square root go away. And if I use an example here, say the square root of 9 times the square root of 9, said 9 root 3. Square root of 9 times square root of 9. That's going to be equal to 9. The square root just sort of wipes away because we're squaring it. And if you think about it a different way, square root of 9 is 3 times square root of 9 is 3. You see that equals 9. But it's more useful if you just remember squaring is the inverse operation of a square root. So if I square this thing, well, what do I get? I take away the square root and I get negative 1. So I squared equals negative 1 and I equals the square root of negative 1. Now I cubed, I'm just going to say that's I squared times I, right? Which means it's negative 1 times the square root of negative 1, which we would simply write as negative square root negative 1. Or you could also write it this way. You could write it as negative I. A lot of people prefer that. And then I to the fourth power, that's just I squared times I squared, which is negative 1 times negative 1, which is positive 1. So oftentimes you'll be asked to write these things and just memorize that I equals the square root of negative 1, and you can rebuild the rest of this. I squared equals negative 1, I cubed equals negative I, and I to the fourth equals positive 1. Okay, and it'll keep going cyclically. If you tried to figure out what I to the fifth was or I to the sixth, you could use the same argument here where you break it into pieces and proceed with that. Now, complex number arithmetic is really very simple. If you know regular arithmetic, you just treat I like it's a variable, like x or something. So in this example, I'll say negative 4 times negative 1, that's positive 4. Negative 4 times negative 3i is positive 12i. Negative 5 times 4 is minus 20, and negative 5 times positive 5i is minus 25i. So that's pretty good. We can still simplify this by combining like terms. 4 minus 20, right? That's the first thing we're going to combine. That's negative 16. And 12i and 25i, those are both imaginary terms. So we're going to combine those. And we get minus 13i. So here's our complex number. It has a real part of negative 16 and an imaginary part of negative 13. It's negative 16 minus 13i. That's how we would say it. Okay, so a little multiplication. If you remember foiling, first, outer, inner, last, I'm going to start, just like I would with regular variables, with the first terms. Negative 3 times negative 4 is 12. And then the outer terms, negative 4 times positive 4i becomes negative 12i. That part's imaginary. And then, give me a little more space for my fancy arrows here. We have these inner terms. Positive 3i times negative 4 makes minus 12i. And then the last terms, the rightmost terms, 3i times 4i gives you 12i squared. And we're going to combine like terms, just like before. We have i's, a pair of I terms. So this is 12 minus 24i plus 12i squared. Okay, now you could stop here, but I would prefer that you don't, because we can simplify this some more. Remember, I squared equals negative 1. So let's take that and put it in here and say 12 minus 24i plus 12 times I squared. And I squared is that negative 1 thing. So this becomes, well, 12 is going to cross out with negative 12, and all you have left at the end is negative 24i, a purely imaginary number. And sometimes that happens. You might get, as a result of multiplying two complex numbers together, you might get a purely imaginary number or a purely real number. You just have to go through the algebra and figure it out.